Okay, hi! If you're willing to study something related with math, the word function is something very, very important for you. But even if you're not interested in math, to me the word function is applied in everything in our life, and specifically to understanding the word function is to pass to another level. Okay? Understanding this word is to move to another level. You will see things different in your life if you understand the word function. And this is what we're going to do. We're going to do the basic concepts about functions. We're going to see some specific facts about the functions like one-to-one and inverse. And the idea is to get it and understand what is a function. Okay? So we're going to start by saying what is a function. Okay, so what is a function? What is a function? A function is something very simple, very simple. A function first is a relation. Okay, a relation, and that's why we use the notation fx, because it says that the function has a relation with x, okay? And it's a relation between two sets. The first set that we call it domain, the independent variable, and the other set that we call it range, the dependent variable. And the only condition is that for one element of the domain corresponds one element of the range, okay? One element of the domain corresponds to one element of the range. For example, what happens if we have this domain here and range here, and it happens that this element of the domain goes to two elements of range. Okay? So if this happens, I'm sorry to tell you that it's not a function. Okay? Not a function. Why is not a function? Because the function should have one element of the domain to one element of the range. Okay? Basically, everything in our life, or most of the things we have in our life, relates an input with just one output. That's why we use functions in many things, okay? And this is the definition of function. Let me repeat it again. The definition of a function is a relation in which one element of the domain corresponds only to one element of the range. This is the basic of functions. And you may ask, okay, if this is a function, how could I represent a function? How could I represent? Okay, basically there are many ways to represent a function. I'm just going to talk about three options, and the first option that I would like to show is something called diagrams or Venn diagrams. You said domain or x, you said here range or y, and the diagrams means that you have here some points that call in the domain, and here some points that are on the range, and we take the relationship saying, okay, this element with this element, this with this, and this with this, and let's say that the rule is fx. Okay, this is the option number one, diagrams. The option number two that I'd like to introduce to you is the graph. Okay, so many functions could be on a Cartesian plane. So, okay, if you're taking notes of this, please use ruler. Okay, not my Scrabbles here. And when we do a graph, we have this form that represents that one element of the domain corresponds to one element of the range. For example, when you have a graph, let me do it with blue. When you have a graph, of this form, we may say that this is not a function. Why is not a function? Because for one element of the domain, this point, there are two elements of the range. So, sorry, not a function. It's a relationship, but it's not a function. And the third option that we can have, or we may study too much, is by equations rule. So for example, when you said fx equals x, we have an equation that relates one element of the domain with one element of the range. For example, if you have an equation of this form, fx to the second power equals 1 minus x squared, this is not a function because you can have two numbers here for x, such as we have fx squared. So I'm sorry, not a function. Okay, so you can represent in three forms: graph, equation, graph, and diagram. And what is a function? Remember, one element of the domain goes to one element of the range. Now, there are a specific set of functions calling one-to-one functions. One-to-one functions. And why we calling one-to-one? One-to-one. Why we calling one-to-one? We call it one-to-one because for one element of the range, corresponds one element of the domain. Okay? It may seem kind of the same as the definition of functions, but we're going to see why it's different. Let's see this function. For example, we have here the domain, we have here the range. Look at that, the definition of one-to-one is for one element of the range corresponds one element of the domain. And the definition of function for one element of the domain corresponds one element of the range. So look at, for example, this function here. I have 3 points. Here I have 2 points. One element of the domain corresponds to one element of the range. Okay? But notice that this element of the range corresponds to two elements of the domain. So this is not one-to-one. It's a function. But it's not one-to-one. Okay? And you may say, okay, why do we need to use one-to-one functions? We may use one-to-one functions because if I have one element of the range corresponds to one element of the domain, I may change the dependent and the independent variable to find something calling the inverse of a function. Okay? The inverse. The inverse only works with one-to-one. If you have a one-to-one function, you can have the inverse. Let me repeat it. If you have a one-to-one functions, you can find the inverse, because it means that you're going to have one element of the range corresponds to one element of the domain, so you can change domain and range, like interchange domain and range. Okay, that's the inverse. In terms of graphs, what happened to the inverse in terms of graphs? In terms of graphs, if you have a graph, let's use blue. Let me do this graph. if you have a graph and you want to find the inverse of the graph, the only thing you have to do is to put a line, the line y equals x, the line y equals x, and the graph is going to be a reflection about this line. Okay, so the reflection of this line is going to be, imagine like this is a mirror, so what we're going to see is this. That will be the graph. Okay, it's not as good as my hands, but I think that you got the idea. And this is the basic idea of functions, one-to-one and inverse. Let me repeat two concepts. The first, remember, one element of the domain should go to one element of the range to have a function. Remember, to be one-to-one, one element of the range should go to one element of the domain. And to have the inverse by graph, you have to put y equals x, and the reflection about this graph is gonna give you the function. And that's it. You can see another video in which I explain operations of functions and inverse of a function. See you then. Bye bye.